So what we are doing, we are going to start with uh, hexagonal bolt and nut. So first, I'm going to draw a hexagonal bolt. Now the problem a lot of you people will have that how to draw. So in exam, they will write axis parallel to HP and VP. So you have to draw hexagonal bolt like this. In side view, you will have hexagon, and in front view, you will have bolt. Right? You can draw this way or this way. Generally 90% of the people are IT, so they prefer it this way. Okay, anyhow it is correct. Then few people, they become extra smart, they draw it like this also. This is also fine, but in this dark and dotted will change, right? So we prefer this when they say axis parallel to HP, and when they say axis perpendicular to HP, so we draw it like this. Or got it? Understood the difference? When they say axis parallel to HP and VP, it will be this way, front view, side view. When they say axis perpendicular to HP, it will be front view, top view. This you should remember. In this front view, side view, in this case, it is front view, top view. So there are two conditions. So what we will do, we will draw a hexagonal bolt like this and square bolt like this. Got it? So first we'll draw hexagonal bolt. So when you have to draw a hexagonal bolt, first I will draw box. Again, same. In this also they will give you D. D is diameter, which is 30. So what we need to find out? We need to find out 0.8D, which is 24, 1.5D plus 3, and 2D plus 6. Now what is this? See, D is diameter. Now when you draw threads, it is like this. See, this way it is. So in this there are two diameters. One is the external diameter, which is DO, and one is inside diameter, which is DI, right? So we have a relationship in the sense DI is 0.8 DO. DI by DO is 0.8. This is standard. At times people take this as 0.82 also, 0.85 also, whatever they want, but we are taking 0.8, right? We are taking 0.8. Understood? So this is internal diameter, external diameter. So here D matlab DO, and this is DI. That's why I'm writing it like this. So this is threading. Now we can't draw threading like this. So what we do, we show threading like this. Like this, we show threading. So this is our external diameter. This is inner diameter. So the ratio between them is 0.8. DI upon DO is 0.8. At times people take 0.8 to 0.85. This you should keep in mind. 1.5D plus 3. So this distance across flat is 1.5D plus 3. If diameter is very, very big, that time we take only 1.5D. But for school exam purpose, we'll take 1.5D plus 3, this distance. And what is 2D plus 6? This thread length is 2D plus 6. This much you should know. Now we'll start with hexagon. So I have to draw hexagon with 1.5D plus 3, which comes to 48, and this comes to 66. So I'll draw 48 long line. I will draw two vertical line, and I will draw middle line. So this is how much? 24, 24. Then I will draw 30°, and I will draw 30° like this. So I'll get this side. So see, this side is important. Take this side, and from here you cut here. This is how you'll get hexagon. Then what you have to do? You have to project. Now first we have to draw head. This is called head. So always remember, head is always in the range of 0.8D to D. So this I'm taking right now 0.8D, but you can take D also. But right now I'm taking this much. Now what we have to do? Now we'll draw this also. So this we got. Now what I will do? I will draw 60° from here. This angle is how much? 60. And this angle also 60. Wherever it will cut from that point to this radius, and we'll draw arc. Got it? Again, from this point we'll take 60°. Wherever it will cut, we'll draw arc. Again, from here we'll take 60°. Wherever it will cut, we'll draw arc. This is how you will get this curved portion for the hexagon. Remember, from here you take 60, 60, right? So that way, so this is also indirectly 60. But this is how you will draw head. Now what we will do, we'll draw one circle here. It's called chamfering circle. So when you draw this chamfering circle, because when you see hexagonal bolt, right, all the edges are very sharp, so you might get hurt. So what they do, they remove those sharp edges, so it will look like this, curves. So that's why we are drawing this circle. Now wherever this circle touches this vertical line, from there we'll draw a line, and we mark that point. So our curve is only this much. This is full curve, but this curve is only this much. And from here we'll draw 30° line. See, this angle is 30°. So this is called chamfering. And from here we'll draw vertical line. This is how you will get head of the hexagonal bolt. Got it? All of you understood this chamfering? You draw this circle. Wherever it is cutting this vertical line, from there you draw horizontal line. Wherever it will cut here, from that point you draw 30°. From here you extend. Wherever it will cut, from that point you draw 30°. This is how you will draw head. Now we need to draw shank length. Now generally they will give you shank length. Now let's say the length of the bolt is 120. So they have given this 120. So I know that thread is 2D plus 6, that is 66. So from here, right, what we will do, once you get this point, so this is 120, right? Then from here you go inside by D and you draw curve. From here you go inside by D and draw curve. So you'll get this point, and this this I need to draw. So here now I have to draw threading. Now remember one thing, when I'm seeing it from this side, I can't see this threading, right? And this is which threading? External threading. If you remember in the last class, like in threading, I had explained that in bolt we have this external threading. So what we will do, the external circle will be full. So that is a representation of threading. That external circle will be full, internal will be 3/4. But since when I see from here, I can't see threading, so I'll be drawing it dotted. So the external circle, which is diameter 30, will be full, and diameter 24 would be 3/4. And remember, we have to leave this gap in first quadrant because we are following first quadrant. See this. This is 24. Because in NCRT they have given in third angle because they have copied directly from the US textbook. Okay, so we'll ignore that because we are following first angle. So remember, we need to leave first quadrant empty. Now, when you draw this, so this part you extend. So when you extend this part, it will come slightly outside. It won't merge with this line. It will be slightly out. Got it? And then you draw this radius. You'll get it. Then you extend this part. And this length you take 2D plus 6. This is 2D plus 6 you take length. And you draw this 30-30 degree. This is again chamfering. So this is how you will draw thread profile. Got it? So this is 0.8D and this is D. Got it? So this is how you will draw hexagonal bolt. Now let's say if somebody has done it this side view this side, he will draw hexagon like this. He will draw head like this. Right? He will again draw curve, then chamfering. This is how you will draw. Now in this case, the chamfering circle would be dotted because when you see this bolt from here, you can't see the circle. I think push this up. So this is front view and side view. I'm saying if you draw front view and side view like this, right hand side view, how it will come. So when observer will see from here, he can see threading. So outer circle will be full, inner one will be 3/4, and the chamfering would be dotted. You understood? So the only thing dark dotted will shift. Otherwise, it will remain as it is. So this you should keep in mind whether you want to draw side view this side, you want to draw left hand side view or right hand side view. If you want to draw right hand side view, then these two dotted will become dark and this dotted will become dot, or this dark will become dotted. It will interchange. Otherwise, there is no issue in this. Then now, so this is hexagonal bolt. The same way we'll do square bolt. So once you draw bolt, you'll understand nut very easily. There's hardly any difference from the drawing point of view. It is almost same. Now we do square bolt. Now in this, I hope everyone understood hexagonal bolt. Any doubt in hexagonal bolt? Anyone? Any doubt? Okay. So in square bolt, axis perpendicular to VP, and parallel to, sorry, perpendicular to HP. Axis perpendicular to HP and parallel to VP. So in this, bolt will come like this. I'm drawing it like this, square bolt. So what I will do, I will draw again box. Will give you value. Let's say the value of D, outer diameter. We know inner diameter 0.8D, which is 19.2, then 1.5D plus 3, whatever value comes, 2D plus 6, and 2D. So what I will do, first I will draw square. So this would be how much? 1.5D plus 3. We'll draw square. We'll draw head. All of you know head. This is how much? 0.8D. We can take D also. Then now, when you see from the top, you can see threading, right? So the outer circle will be dark. Inner one will be 3/4. See, outer circle diameter is how much? 24. Inner circle diameter is how much? 19.2. And then you extend 24 the shank length they will give, right? You go down by D and you draw curve. This is how you'll get this 2D plus 6, 2D plus 6. Got it? Now we have a chamfering circle. But since you can't see chamfering circle, when you see from here, you can't see chamfering circle. So it will be dotted, right? And to draw, what you do from center, you go up by 2D and you draw arc. This is that chamfering. So this is how you will draw square thread. Got it? So in textbook, it is given like this. If you see this open part is in third quadrant. And what I have done it in first quadrant. So this is correct because we are following first angle. In India, we follow first angle. That's why we keep it like this. So when you are referring to any textbook, check this first. Got it? Square bolt. Then we have nut. So any doubt in square bolt? It's very simple. Once you do hexagonal bolt, then square bolt is very simple. Then all these dimensions, 2D plus 6, shank length, and all this you can do. Now nut. So nut, again we have table. We'll do hexagonal nut first. So we have D, 0.8D, 1.5D plus 3. In certain engineering textbook, you will see only 1.5D. So don't get confused. Okay, people can take 1.5D also. When diameter is huge, they ignore 3. That's fine. So when I'm drawing hexagonal nut, what I will do, I will draw hexagon first. How will I draw hexagon? Same method. 1.5D plus 3. Remember, same method. I'll just explain. You draw line. D is how much? D is 30. So 1.5D plus 3 is 48. This is 24. So you take 48, you take midpoint, and you draw 30 degree. So you get the side of the hexagon. Once you get side, from here you cut here, from here you cut here. So this is how you'll get hexagon. And then you extend this up. You'll get this head of the nut. Now this you will take generally D. See in bolt, we used to take 0.8D. In nut, we'll take D. And then we extend this, right? Now in this again, we'll do the same thing. We'll draw 60 degree from here and 60 degree from here. Wherever it will cut, from there we'll draw arc. Again, you'll draw 60 degree from here, 60 degree from here, wherever it will do, we'll draw arc. Now we need to draw chamfering circle. So I will draw a circle over here, touching all the sides from the center. So wherever it will touch, see, this is horizontal line. So wherever it is touching this circle, with this line, I'll go up. So that is the point. So only that much portion is dark. And then you draw 30 degree chamfering. See why I'm drawing this dark, so you will know. In reality, you don't have to draw that much dark. You need to draw only this much. This is the extra portion, but I'm just showing you so you will know that I have done chamfering over there. If you see my video, you will come to know. So this is how you will draw. After that, I need to draw threading. See how is hexagonal nut? Hexagonal nut is like this. This is threading. This is which threading? Internal threading. So the inner one will be dark and outer one will be 3/4. Got it? So what is this diameter? Outer one 30. Inner one 24. And you draw dotted. This you can't see now in front view, so it will be dotted. This is front view, top view of hexagonal nut. You want to draw side view, you can draw side view. If you don't want to draw, it's okay. Generally, they don't ask side view. You can practice. Same thing will come for square nut. If you want to draw square nut again, you'll have table D, which is 25.8D, which is 20, and this is 1.5D. See, in this, he has taken 1.5D. It's okay. So we'll draw 1.5D. Front view, that is head. This is front view, this is top view. Why I'm drawing like this? Because I'm assuming X is perpendicular to HP and parallel to VP. Right? Generally, they will ask you this only. But if just in case, if they say X is parallel to HP and VP, so then you draw this in side view. But I don't think so they'll ask you like that. So you draw this 1.5D. So don't get confused. You can take 1.5D. So here they have taken 1.5D. They have taken this as D. Now, if they want to draw arc, what I have to do? From here, I will go down by 2D. Remember, here we did the 2D. Here also 2D. You take this distance and you draw arc. This is how you will get that radius. Then same method. Inner circle will be dark. Outer one will be 3/4 because it's an internal threading. And chamfering circle. In this, there is no question of 30-30 degree. This you extend, dotted. You'll have 4 dotted line. Got it? So this is how you will draw square nut. So for this dotted line, you project from here. When you draw this in top view, this you know diameter 25, and this is diameter 20, right? It's given, na? 25 and 20. So you draw that and you extend this line that is dotted. Extend this line that is dotted. So these 1, 2, 3, 4, 4 lines, dotted lines, we are getting it from the top view. Got it?
Got it, sir.
Okay.
Yeah, sir. Also, can you explain that square bolt that you made pehle with the shaft length?
This.
Yeah.
Okay. This they will give you. They'll give you somewhere around 120 or 90. They will give you. So you take that much length. You take the center line. From there you go inside by D, and from there you draw arc. You go inside by D and you draw radius, and then you extend this. This though you know, na? This diameter you know, it's 24, and the inside one you can project from here if you want. And this angle is 30-30 degree. This is called chamfering, and this from here it is 2D plus 6.
Got it, sir.
Got it? Okay. Any doubt? Anyone?